My name is Oliver Freeman. I'm the technical architect for the NIHR Oxford BRC Clinical Informatics Group. And I'm going to give you a Wayfarer's Guide to the Galaxy of LabKey inside the NIHR Oxford BRC. First of all, don't panic. I might be a technical architect. I'm not going into technical extremes of technical stuff because I could bore you silly with that. So I was joking yesterday with some of the guys. My job title, the team I work with, we have the most insane amount of acronyms going on. So I'm going to give you a brief sort of who we are and what we do, and then I'll go into the actual LabKey instances. The point of the talk is really to show you a couple of the instances that we have and how we manage all of the instances that we have in a sort of least amount of effort possible. So firstly, the NIHR is the National Institute for Health Research. It's a government-funded body which covers a lot of the trusts and NHS trusts across the country. The BRC, which is the Biomedical Research Centre, is a funded collaboration between a university and a NHS trust. There are 16 of them at the moment in this current round of BRC grants. The first one there were 5, this time it's 16. The third grant system is 2022, and I'm assuming we'll have more, but that's if the government has got any money. Our collaboration is between the OUH, which is the Oxford University Hospitals NHS Foundation Trust, and the University of Oxford. Just for clarity, you might think, hey, he's got university in the hospital name, why has it not already got a collaboration? It's just because most of the NHS hospitals group with the university for the training. So if you do a medical degree, this is where you do your actual medical training. There isn't any formal agreement for extracting medical data from the trust and using it inside research inside the university itself. That's not to say that research doesn't happen, but it's always inside the NHS itself. So the BRC was trying to say, you've got this wealth of information, can we not try and sort of share it? I work for the Clinical Informatics team. We were for a while the only team of our kind. We are the largest team of our kind in the country. We are currently up at 16 members. We basically are in charge of providing services and grouping the data that's available inside the trust and helping the university teams or the trust research teams in actually gaining access to this data, because as one would hope, it's not all in one location. It's spread out currently over at least 100 different databases and data sources. So we try to collate it all, make an understanding of it, and then provide it in an easy way and manner to the research teams themselves. It's not easy, and we still haven't perfected it. But everybody keeps looking at us as the way to do it, and we're like, we don't know what we're doing. We really don't. So the first project I'm going to talk about is one that's actually been around for a while, and I discovered 2 days ago that it was presented at this conference 5 years ago, so I feel really good about that one. It's the Oxford Hepatology Research Project. This was set up to use LabKey for data collection. The Hepatology Research Project is used for data collection for patient research care. It's used by the Hepatitis Clinic in Oxford, which doesn't actually have a formal EPR or EHR. And they wanted to sort of collate a lot of the common data points that were used for research inside hepatitis, rather than just having it in free text notes and somebody has to manually extract it all. So the guys came up with a LabKey actual proper study data set. It has 37 data sets across 6 different cohorts. Those cohorts are like autoimmune hepatitis, hepatitis B with delta co-infection, Hep C, Hep E, and other. I'm not entirely sure what other is, but it exists. It was built back in 2015, and we had actually had a problem recently where it was originally built using one of the original study dataset styles, which was the date or visit style. We imported a large number of lab tests into the system and stopped it working because it was just got too big. So in 2019, we actually updated it to use the new form of continuous style because we actually didn't care about the date visit format of the study data set. We were more interested in the individual data points, and as every data point had its own date attached to it, we weren't too bothered about when it was physically entered into LabKey. Didn't actually take too long, because when we did the update, we basically moved all the data by exporting it in Excel and then just re-importing it into a new study. One of the beauties of LabKey. So what we did, apart from creating the study data set, was design a custom JavaScript UI to sit on top of the LabKey UI. This was designed in close collaboration with LabKey. a lot of discussions back and forth about how to do it, what the best way of doing it, and to use LabKey's JavaScript API. And it was originally built using JavaScript and jQuery. And last year now, LabKey updated their front end to use Bootstrap and React. And we're in the process of actually updating and rebuilding the interface to use the React and Bootstrap interface junctioning rather than using old school JavaScript and jQuery. We just don't have enough resources to do it, so we're sort of working through it slowly. Why did we do this? Inside the, physically inside the hepatitis clinic, using LabKey, I sort of say that data inside LabKey is usually presented in a research-centric form. You can see all the data points for everybody. Inside a clinic where you've got other patients, that's not really allowed, so we needed to provide a sort of single patient-centric front end, which made it easier for the nurses to actually view the data and to enter data just for that one patient, and it also allowed them to add it and edit the data while they were physically in front of the patient themselves, as opposed to doing after the fact, because if you try and persuade nurses to do something after the fact, it usually doesn't happen. One of the nice things we obviously like about the LabKey study functionality is then we were able to connect to it with R and R Studio to do actual research. We didn't at that point care about the patient-centric, we just want data. And obviously the nice searching and charts reporting to then provide data out for our various research projects. So what did we actually do? Unfortunately, I don't know, the guys at the back have actually got a much better view we discovered earlier with the giant. Is it not on? Oh, it was working half an hour ago. Oh, well. Okay, basically, this is, for those of you, I think everybody here is familiar with LabKey. This is the standard LabKey. You've got data views here and giant tables, which are super useful if you're doing research. What we did is we laid over the top a sort of an interface where you can pick the cohort, you can see a list of the patients, and then you can select an individual patient and see just that one patient's data down the bottom. You would then be able to click on, I don't know, the problem is I don't know how well you guys can see it. Basically, we've laid out all of the data sets as tabs, and you could then basically click each tab and see just that one patient's lab test results or demographics very, very quickly and easily. And using the standard, you can edit and add or change or remove any entries that you want. We didn't do anything particularly fancy. For any of you who are used to using LabKey, that should look very familiar for when you want to create a new entry or edit a new entry. All we did was pull out LabKey's interface and overlay it into a slightly more sort of fancy-looking box, basically. But it does the job. So we were able to then basically make it so that nurses could see everything easily. Nice little click button, made it nice for them. Other problem we confronted was lab test results. You don't want nurses entering lab test results. They don't have time, and you've got to wait for them to come through. We wanted them immediately. So obviously, problem is standard EPR usually connects to the lab test system, and it's loaded in automatically. LabKey wasn't. However, we can do, thanks to the beauty of the LabKey ETLs. So what we do is we extract all the patients that are inside the hepatology clinic into a subject of interest table, which sits just outside of the actual LabKey database. We then use our clinical data warehouse to run through that list, identify all the relevant lab test results, and load them into a table in a table inside the data warehouse. And then we use another ETL to extract all that data back out again into LabKey itself. This is a pretty picture of how it works. This happens on a daily basis. So this is our LabKey instance with the research study and the Postgres database itself, which is the LabKey-based database. And basically, we use the LabKey ETLs to drop it into a table over here in a completely different server. We then have the data warehouse doing its lovely sort of mapping and extraction into here, and then we have a little ETL to yank it back over here, and it's deployed straight into the lab test data set itself, so it immediately appears inside LabKey without anybody actually having to do anything. And this has now been running for 4 years, and this is the reason why we had to update to continuous, because we updated it to be a little bit more fluid, and we ended up loading, I think it was 30 million lab test results overnight, and it sort of slowed down. LabKey, actually, ironically, LabKey was perfectly happy viewing it. It was only when we went to try and add or edit the entries, add or edit any more entries. But actually viewing the data, LabKey was perfectly happy with it. And that's what we found. LabKey's always happy viewing data in study data set. Doesn't matter how much you have. which is really great. So that's off. We use LabKey in a lot of different forms. The study dataset is obviously one of the most popular, and that's one of them. The other one that we do that I'm going to show off today is the Health Informatics Collaborative, or yet another acronym, HIC, the hepatitis theme, sticking with a common basis theme here today. So the HIC, as a basic sort of overview, is data sharing between various different NHS trusts. The idea is that we've obviously got common problems across the country, and we just want to share data. It all has to be anonymous, but if we can share all of the hepatitis data, all of the hepatitis patients across the country, we can do research and sort of maybe identify helpful things. Oxford is the coordinating centre for the whole lot, but then each of the individual NHS trusts might be the lead for a particular theme. In this situation, Oxford is also the lead the theme lead for hepatitis itself. So what we do is we collect all the data using XML, and that's loaded into the Oxford Data Acquisition and Management System, which we built and then recustomized for GEL, which, if anybody was here 3 years ago, I think, GEL did a presentation. So we repurposed it for them, and we're using it again for HIC. It's validated through XML, loaded into an external schema. So in this situation, we don't actually use LabKey study dataset. We load them into an external database, and then we then serve that database up to researchers using LabKey. So just sort of an overview of the actual data acquisition management system. Basically, we've got a HIC collaborator. They drop the files in to a location. They're processed through a nice Docker service build, which does all validation, returns emails if it fails, and then loads them into a database, which we then have LabKey, which looks at it, and they can then look back at what's been loaded. So how do we actually use LabKey? We use LabKey in a multitude of ways. With GEL, they insisted on using SFTP for file sharing. We were like, why are you doing that? You have LabKey. You can use LabKey's file drop system. So we serve up and provide LabKey where people can just upload their files directly into LabKey, into the inbox folder. They're then processed in the background. The nice thing is here is that they can then come back in and see the files that have been processed, and if we've got any problems, they can re-download them if they've, say, deleted them, and have a look at the XMLs that failed. It also allows us to see what's been dropped and what hasn't been processed without actually having direct access to any servers in the background or any SFTP servers that might be all liable to crash. So this was super useful for us. Data viewing then. In this situation, as I say, what we do is we use LabKey's external schema functionality. So we serve up, we connect directly to an external database, and we basically provide, these are actually all custom-built queries, so the underlying tables are hidden because we reorient the data slightly, and we provide custom queries which are defined in a LabKey module that's loaded when LabKey starts, as opposed to, so which means that the nice thing is nobody can go in and mess with that after I've spent months making it perfect. Nobody can go and change it. But all of these connections to these databases are read-only. We don't want people logging in and editing the data. And it provides the standard LabKey functionality, which for us especially is the external analytics. So when they then log in, they then see a page with all of the reoriented tab views, which they can then grid view and have a look at each of the various areas. Most importantly for us, this is shared on the NHS N3 network, which is a network inside the UK where anybody who has an NHS account and is inside their particular relevant trust's network can gain access to it, which means that technically, if somebody accidentally adds somebody, we can see everything they've done. For us, LabKey's auditing capability and its permission structure is really, really great. I had better words, but I've forgotten what they were. The ability to audit what people are doing at that level, for us to be able to know who's run what queries, who's looked at what data, especially when people then sort of try and do something suspicious. And then the ability to say, in this particular section, we have a folder that only certain people can see. And the really big thing for us is that nobody has direct access to the database. Managing database direct access, just once you start hitting a certain number of people, thinking about 10, more than 10 people, it just becomes too much for people like me, and I would much rather have group level access, and the ability to group level access and folder level access inside LabKey means that I'm not reliant on anybody else, and it's just there and available. The other thing which we use with the Hepatology Research Project, and also with our other major project we use this for, which is our data warehouse, is we use the LDAP system that's built into LabKey. This for us is really, really good because it means that we don't actually have to manually create any users. We just tell them to log in using their Oxford University accounts. Their account is all automatically set up. We can then add them to the relevant groups. If they get let go or they quit, we don't actually have to go in and delete them because the LDAP system says you're no longer authorized to access LabKey. It's not we can then go in on a 6-monthly basis and just do a cleanup. Not that people leave that often, but if we had to. So for us, the ability for that LDAP, that authentication, that group level access, inside the clinical data warehouse, we provide all of our data products that we build. We are all served up using this external schema form to any of the researchers. Each folder, each data product that we produce is stored inside a folder, and only the people in that research project can see that folder. So whilst we have LabKey, we currently are serving 15 different data products in that one LabKey instance. We know for a fact, and we can show conclusively to the researchers that other researchers cannot see their data, despite the fact they've all got honorary contracts and therefore legally, technically are allowed to, but they're happy that nobody else can see their stuff. So the other thing is, we are obviously, as you can tell, we're running 2 that I've just talked about. We have 3 that we just talked about. This is a short list of the other instances. I did the maths this morning. We're currently running 10 instances of LabKey, all doing completely different things. You reach a point where this becomes impractical to try and manage a sort of server admin using old-school server techniques. So we spent quite some time looking at the various ways that we could do it, and we came up with our Docker compose files. So for those of you not familiar with Docker, this is where I get a little bit technical. Basically, Docker is a container-based and operating system independent concept. You basically package up everything you want inside a Docker image, and then you just provide the image itself, and you can run it up on Windows, you can run it up on Linux, you can run it up on Mac, and you know for a fact that it's running the same system every single time. So it doesn't matter where we do it, doesn't matter who does it, we know that it's going to work. We also use it to separate out the Postgres and the Tomcat instance, which means we can update one without touching the other. The other really nice thing is that it creates an internal network between the 2 containers. So a lot of security teams, like, oh, you're running Postgres, you're running Tomcat, those are exposed to the outer world. We don't like people having access to Postgres. You can't run it on that particular server. We're like, but it's not exposed. The Postgres container, when it's up and running, doesn't expose anything. The only thing that can physically talk to that Postgres container is that Tomcat container. So we know for a fact that nobody can get physical access to that database. And then Tomcat is a stripped down, really bare bones version that's just running LabKey. It's really quick and easy for us to update. All I have to do is go into the relevant Docker file, change a couple of parameters, literally change a couple of numbers to update the version of, say, LabKey, redeploy that across using Git across all my servers, and then do docker compose up. It rebuilds the image completely and brings it back up again. It's about 30 seconds work on every server instance I'm running, as opposed to a couple of hours work in old school technology. The reason that we use this, so LabKey have done a lot of work to get everything running inside AWS and provide hosted solutions. We have problems in the fact that inside the NHS itself, each local NHS instance, they're not allowed to have data leave the NHS estate in the virtual concept. So we can't push data to AWS. We can't push data basically outside of where we are. So unfortunately, we can't take advantage of the beautiful AWS builds that you guys have got that run up super quick. But this essentially does the same thing. It allows us to say to people, you want a version of LabKey? Here you go. Run it up, run this, run it up, and it'll all be working. And it requires no input from us. The other really nice thing is that we can run multiple versions of LabKey on the same physical server. A little bit more technical stuff. If you've got one server, typically running up multiple versions of Tomcat, multiple versions of LabKey, multiple versions of databases requires a lot of config time because you've got to set up all the ports and make sure nothing's crossing over and making sure that everything is nicely working. Because of Docker, everything is self-contained. So that's one LabKey instance, and that's another LabKey instance, where these are the only things talking to themselves, and then the database files are then stored out for backing up. But there's no crossover, there's no time. We don't need to waste time setting up any configuration. All we then have is a simple web proxy, which basically balances when the user balances which of those LabKey instances they go to. So makes life nice and easy for us, and it means that we can have one server running 10 instances of LabKey, which are all various versions, depending on where we've got to with updating. I think one of our versions we're still running LabKey 15, which, you know, we're in the process of updating it. So thank you very much. I've actually managed to cut it down quite considerably. So if anybody's got any questions, I've got time to take questions now, or I'll be in the DevOps discussion afterwards, or people can always ask me as well later if they want to get a bit more technical info.